Today's topic is arithmetic progression. It has been newly added in the syllabus for the 2018 board exam onwards. This can very much come one question in section A. Okay, it is a middle level topic. It cannot be categorized as a difficult topic. Let us see these numbers 7, 10, 13, 16, 19, 22. If you see, they progress in a particular fashion. 10 minus 7, 3. 13 minus 10, 3. 16 minus 13, 3. 19 minus 16, 3. 22 minus 19, 3. So here we note that the difference is the same throughout. The difference is the same throughout. Such things, this pattern is now known as arithmetic progression. We will study some technical terms. Note the difference should be the same throughout. Here 7 is known as A. A we call it as the first term or the opening term. So here A will be 7. Now D. D would be second term minus first term. So it will be 10 minus 7, that is 3. So the common difference is 3. 22 is my last term in this case. So we write T suffix n, the nth term. The nth term here is 22. Now see 1, 2, 3, 4, 5, 6. Altogether there are 6 terms in this AP. Now henceforth AP means arithmetic progression. Short forms are allowed in the exam. You can write like this, A dot T. So A will be the first term in this case. D will be 10 minus 7, that is 3. 22 will be the last term. Now 1, 2, 3, 4, 5, 6. So we can say that T6, because 6 is the last term, 6th term. So T6 will be 22. And N will be how much? 6. You should not confuse between T6 and N. N stands for the number of terms. N stands for the number of terms. Whereas T6 denotes the value of the 6th term. Now that value could be anything. In this case it is 22. What would be T3? First term, second term, third term. So T3 would be 13. What would be T5? Fifth term. First term, second term, third term, fourth term, fifth term. So T5 would be 19. So far comfortable? This AP is known as increasing AP because the numbers are going on increasing. You can have decreasing AP also. I will show it to you. Now there are some formulae here. Actually, basically, they're simple logic converted into formulae for the sake of convenience. if we wish to find the nth term of an AP, now how do you find the third term of an AP? You see the common difference, take the first term, add common difference, get second, again get this. So going by this logic, we have Tn, T suffix n. Tn means nth term of the AP. Now here I have given you first term, second term, third term, fourth term, fifth term and sixth term. What if I want to, if I continue this pattern, what if I want to know the 12th term? So instead of actually going step by step, we can directly get the 12th term. So in general, Tn, that is the nth term of an AP, will be A plus n minus 1 into D. Okay, there is a simple derivation for this formula. We have to see how many gaps are there multiplied by the common difference. But due to paucity of time, I am not going into the derivation of this. So remember Tn, the nth term of any AP will be given by the formula A plus n minus 1 into D, where A stands for the first term, n stands for the number of terms. Like here, there are 1, 2, 3, 4, 5, 6, that way. And D stands for the common difference. Now let's see if this formula works. I want to find T4, fourth term of the sequence. I want to find fourth term of the sequence. So that would be A. This sequence starting is 7, fourth term. So 4 minus 1, 3 into the common difference. What is the common difference here? 10 minus 7, 13 minus 10. Always second term minus first term. So common difference is how much here? 3. So into 3. So this would be 7 plus 3 into 3. So that is 7 plus 9. That is 16. So the fourth term of the sequence is 16. Now since we already knew the sequence, we can judge whether it is correct or not. First term, second term, third term, fourth term. We also got T4, fourth term, as 16. So this formula is proper. Now, there is one formula for the sum of the numbers in an AP, sum of the first n terms. What if we wish to add up everything and then get? So the formula is, so this is the formula for finding the nth term. Now the formula which is being shown to you is to how to add up all the numbers of a given AP. So we say Sn, S suffix n. Sn means the sum of the first n terms, the sum of first n terms of the given AP. The formula is n by 2, 2a plus n minus 1 into d with usual notations. N stands for number of terms, A stands for the first term, D stands for the common difference. Okay. This formula can be further simplified. It can be written as n by 2 bracket open first term ft, first term plus last term. Definitely both these formulae are connected. I'll show you the connection between the two quickly. 2a can be split as a plus a. So it will be a plus n minus 1 into d. Now first a comes down, that is the first term. Then what is remaining is a plus n minus 1 into d. That is what Tn, the nth term of the sequence. That is the last term. So plus last term. So we can use either of the two formulae depending upon the given data. So we saw what is an AP, how to find the nth term of an AP and how to find the sum of the numbers in a AP. This was the case of increasing AP. Now I will show a quick example of a decreasing AP. Consider 20, 15, 10, 5, 0, -5, -10. Observe that the first term is 20, second term is 15, then 10, then 5. So it is going on decreasing. So this is an example of a decreasing AP. Here the notations remain the same like the previous. A is 20, the first term. D is the common difference. Take care, it is second term minus first term. Second term minus first term. So it is 15 minus 20. So here D will be -5 and not 5. Now quickly tell me what will be T7 here. 1, 2, 3, 4, 5, 6, 7. So T7 is -10. Now this is what we know. But what if we want to find T7? Same formula as the previous. Suppose I would have taken the AP till here and then put ... and you have to predict the terms. So T7 will be, what is the formula? Tn is A plus n minus 1 into D. So T7, the seventh term, will be 20 plus 7 minus 1, because n stands for what? Number of terms. So we want to find the seventh term. So 7 minus 1 into -5, that is 20 plus 6 into -5. So 20 minus 30, which is -10, and it is confirmed it is correct. This way we can find the 8th term, 9th term, 15th term of this particular AP. So this was an example of decreasing AP. So we saw increasing AP, we saw decreasing AP, we saw how to find the nth term of an AP. We also went through the formula how to find the sum of the numbers of a given AP. Same formula like the previous, whether it is decreasing AP or increasing AP doesn't make a difference. So now we are done with the concepts and we will start with the sums. Question 1. Check if 21 is a term of the AP -11, -7, -3 ... up to 49. So this is an AP, it starts with -11 and goes up to 49. Also find the value of the middlemost term or terms of the AP. Okay. Let's sort out the data. What will be the first term? AP is now arithmetic progression. A is -11, that's the first term. D is what? Second term minus first term. So -7 minus -11. -7 minus -11. It is second term minus first term. So that is -7 plus 11. So that is 4. Okay. We want to find if 21 can be a term of the AP or not. Now, if you go on doing this practically, we will come to know. But then it is not that easy that we do -11, -7, -3, we go on continuing. You know, sometimes this AP could go up to 100, 200, 300. We cannot just perform the experiment like that. We need to have some logic to understand whether 21, is it possible for 21 to come if this AP starts from here and goes in this particular pattern and finally touches 49. So what we do, we say Tn is A plus n minus 1 into D. The nth term is A plus n minus 1 into D. Now let's assume for some time that 21 is possible. So the nth is 21. So below Tn we write 21. The nth term is 21. Let's assume, okay. A is minus 11 plus n minus 1 into D. D is 4. Now we will work out the value of n. We will work out the value of n. If n turns out to be a whole number, then 21 can be the term, not otherwise. See, you can have first term, second term, fifth term. How can you have 5.5th term? We can have seventh term. Now, seventh term can be a decimal. That's not a problem. Okay, we can have even decimals. But you cannot have 7.8th term, right? Either it is the seventh term, or it is the 8th term, or it is the 9th term. So whenever you want to check if 21 is a term of the AP or not, basically you should, let's assume that 21 is some term, find out the value of n. If n turns out to be a whole number, okay, then 21 will be a term, otherwise not. So let's work out this. Minus 11 plus 4n minus 4. So we will have now 21 plus 11 plus 4 equaling 4n. So this comes to 32. 32 plus 4, 36. So 4n is 36. So n is 9. Therefore, 21 is possible. If you continue the sequence, the 9th term, n is 9. So your 9th term will turn out to be 21. Now suppose if n would have turned out to be something like 12.5, decimal number, not a whole number, then we would have said no, 21 cannot be the term of the sequence. But here we got a proper answer for 9, a whole number, n is 9, thereby indicating that the 9th term of this sequence will be 21. So this part is over now. Check if 21 is a term of the AP. Now we are telling you also find the value of the middlemost term or terms of the AP. Let's decipher this question. So this I will now erase. So we will have to write, yes, 21 is a term of the given AP. Now, how to get the value of the middlemost terms? Just observe first 1, 2, 3, 4, 5. Suppose there are 5 terms. What they are we don't know, but there are 5 terms. So which is the centermost term? This one, the third term. Okay, because 2 terms to the left, 2 terms to the right. So 1, 2, 3, 4, 5, 6. If there are 6 terms, now how will we find the centermost term? I cannot take this term as a centermost term. If I take it, then to my right I have 3 and to my left I have 2. So then we will have centermost terms. Here there is one center term. But in case if there are even numbers, see 1, 2, 3, 4, 5, 6. So here n is 6, here n is 5. So if n is 5, it's like median, centermost terms like median. So here centermost term will be n plus 1 the whole upon 2th term. This one will be the centermost term, what you have studied in statistics. So see, if I have 1, 2, 3, 4, 5, put n as 5, 5 plus 1, 6 upon 2. So third term. Okay. Here 1, 2, 3, 4, 5, 6. There are 6 terms. So we cannot get the centermost term. We can get the centermost terms, plural. So this will be n by 2th term plus n by 2 plus 1th term. So n is what now? 6. 6 by 2, third term, plus, actually there is no need to add because we just want to find. We are not here finding the median. So we won't be adding. We want the centermost terms separately. So when n is even, we will have n by 2th term. So that is a third term, comma, n by 2 plus 1. See, be careful, it is not n plus 1 the whole upon 2. It is n by 2 plus 1. So it is 6 by 2 plus 1. That is the fourth term. So if n is 6, which will be the centermost terms? It will be the third term and the fourth term. If n is 5, then which one will be the centermost term? Third term. Okay, now quick judgment. If n is 11, then which one will be the centermost term? The sixth term. If n is 18, if there are 18 terms, then which one will be the centermost terms? It will be 9th term and 10th term. So is this fundamental clear? So now we will apply this in this case. Now to find the middlemost term or terms, we will have to first understand how many terms are there. Then we can decide. So that means we have to find n. How many terms are there in the AP? That means we have to find n. So A is minus 11. D, as we saw, is minus 7 minus 11. I'm just doing it once again for your understanding. That is 4, and n is equaling question mark. Now Tn is equaling A plus n minus 1 into D. The nth term of the AP will be A plus n minus 1 into D. Here the last term is 49. So we take Tn as, say, 49. A is minus 11 plus n minus 1. So n will remain as it is because we do not know how many terms are there in the AP, but the nth term is 49 and this is the first term. So we are trying to find out how many terms will be there in the AP. So Tn and n are not the same. N stands for number of terms and Tn stands for the value of the nth term. D is here 4. Solve the equation for n. Minus 11 plus 4n minus 4. So 49 plus 11 plus 4 is equaling 4n. So this will be 59, 60, 64 is equaling 4n. So n will be 16. So there are 16 terms in this AP. So that is number of terms are even. Number of terms are even. So how will I get the centermost terms? Will I get one term or will I get two? Remember, if there are even numbers, even number of terms, then you will have two centermost terms. And if number of terms are odd, then you will have one centermost term. So here now the middle terms will be, just recall that formula or go by logic, take half of this, it will be 8th term and ninth term. 8th term and 9th term would be our middlemost terms. So now basically we have to just find their value. So we have to find T8. So it is A plus n minus 1, n is 8 here, into D. D is 4. So minus 11, this is 7 plus 28. So that would be 17. So if I go slowly, step by step, the 8th term of this sequence would be 17. Now similarly, you can find the 9th term, T9. This sum is now complete. Question 2. For what value of n are the nth terms of two APs? There are two different APs, the same. Also find that term. And they have given these two APs, 63, 65, 67, dot, 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 it continues. 3, 10, 17, dot, 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 it continues. Now what will happen is, this AP is galloping slowly. See, the difference here is only 2. Here the difference is 7. So it is quite possible that at some point of time, there will be one term which will overlap. The same term will come here and the same term will come here. Now that is what we need to find out. Okay, if n turns out to be a whole number, then okay, then there will be some particular term which will be same to both the APs after some point of time. If n does not turn out to be a whole number, then these two APs will not have any common term, no matter how much ever you continue them. So we will have case 1 and case 2. Here I am taking the first AP. So now we will go quick. A is 63, D is 65 minus 63, that is 2. Here A is 3 in the second AP, D is 10 minus 3, that is 7. So we find here Tn. Tn will be A plus n minus 1 into D. So 63 plus n minus 1 into 2. This is some nth term of this first AP. Here again Tn will be A plus n minus 1 into D. Now they are saying you that for what value of n will the nth term of this, some term of this, maybe the 9th term or the 10th term, will equal the 9th term here. The values will be equal. So then now we will have to equate both the terms, because this stands for nth term of first AP, this stands for nth term of the second AP. For what value of n will both of them be equal? So 63 plus n minus 1 into 2 is equaling 3 plus n minus 1 into 7. Solve the equation for n. So 63 plus 2n minus 2 is equaling 3 plus 7n minus 7. So now what we'll bring it here, minus 5n, 3 minus 7 is minus 4, plus 2 minus 63. So minus 5n will be minus 2 minus 65. So n is 13. That means the 13th term of this AP, like this is the first term, second term, third term, go on. The 13th term of this AP will be something, and the 13th term of this AP also will match with that. That means the 13th term of the first AP is same as the 13th term of the next AP. The question says also find that term. So now we have come to know that the 13th term of both the APs will be equal. But now we are interested in knowing what is the value of that term. So you can put n as 13 either here or here. So we will find T13. I will use the second case. It will be 3 plus 13 minus 1 into 7. So 3 plus 12 into 7, 84. That is 87. That means 87 is this particular term which will appear here in the first AP and it will also appear in the second AP. You could have put n as 13 in this. You would have got the same answer. You want, you can check it. N is 13. So 13 minus 1, 12. 12 into 2, 24. 24 plus 63 is 87. So have you got the pulse of the sum? Comfortable with this? Question 3. How many numbers lie between 10 and 300? In between 10 and 300, that means 10 and 300 cannot be considered. Which when divided by 4 leave remainder 3? How many numbers lie between 10 and 300? So because they said in between 10 and 300, so 10 and 300 cannot be considered. Which when divided by 4 leave remainder 3? Now see, if the remainder is 3 and you are dividing the number by 4, the number should be of the type 4k plus 3. Right, because if it is of type 4k, then it will be divisible by 4. But they want a remainder 3. What is remainder? Surplus. So it is, the number will be of the type 4k plus 3 for all whole number values of k. Okay. So what will be our first number? We need to generate our first number, second number, third number. Then only we will get some pattern and we can proceed. So k will be, if I take k as 2, 4 2s are 8. No, it's of no use because then it is between 10. So it has to be more than 10. So if I take k as 3, so 4, no, if I take k as 2, 4 2s are 8, 8 plus 3 because number is of the type 4k plus 3. That means the first number has to be 11. If I put k as 3, first k was 2, so 4 2s are, say if you put k as 1, you will get 4 plus 3 7, but then that goes outside our condition range. So take k as 2, so 4 2s are 8, 8 plus 3 11, okay, this fits in. Now take k as 3, 4 3s are 12, 12 plus 3 15. Now we have got the pattern. You can get k as 4, 4 4s are 16, 16 plus 3, 19. Have you got the AP? Yes. See, 11, 15, 19. So the gap is 4. Everywhere the gap is 4. So now we have got hold of the pattern. But we will have to go up to the last number. The last number is 300, but then our answer has to be less than 300. So k, if we take it as say 50, 50 into 4, 200, 203, no, we are quite far away. So we take say 299. If we take our last number as 299 or say 298, because 300 can't be taken because it has to be less than 300. Now if you take 298, is it divisible by 4? 4 7s are 28. 4 4s are 16. No, it leaves a remainder 2. But what do we want? We want that this number, any number when divided by 4, should leave a remainder 3. So then we can take this as 299. So then it will be 9 here, yeah, and this remainder will come 3. That means the last number which satisfies the given condition will be 299. The last number which satisfies the given condition will be 299. So we have now generated the AP. The question says how many numbers are like this. So what we have to find? N, number of terms. So the problem reduces to finding the number of terms. So N is what? So now this is an AP with A as 11, D as 15 minus 11, that is 4. Now Tn is A plus N minus 1 into D. What is the last term here? 299. A is 11 plus N minus 1 into 4. So now what you have to do is just solve the equation for N. And remember, last number when you are finding out, that should be the maximum possible number satisfying the given criteria. So now this will be 299 is 11 plus 4n minus 4. So 299, 11 minus 4, 7. We bring it here is 4n. So 292 is 4n. So 4 7s are 28. N is 73. That means there are 73 numbers in between 10 and 300 which satisfy the given condition. So now we can extend this sum by asking you to also find the sum of these all such numbers, 11 plus 15 plus 19 up to 299. And how many such terms are there? From 11 to 299, 73 terms. We found out the value of n. So now we want to find S73, sum of the 73 numbers. So the formula will be n by 2. So that is 73 by 2. Now we can use 2a plus n minus 1 into d, no problem. But the second formula is convenient. N by 2, bracket open, first term plus last term. Because we have the last term and we have the first term. So the second formula will be more convenient. First term plus last term. Do not divide 73 by 2 like that. You leave it, let us see, it will get cancelled. So 299 plus 11. How much? 310. See, now this gets easily cancelled. 2 1s are 2, 2 5s are 10. 155. So 155 into 73, whatever that comes out to be, will give you the grand total. So this completes your question 3. Question 4. The sum of first 3 terms of an AP is 33. The sum of first 3 terms of an AP is 33. If the product of the first and the third term exceeds the second term by 29, find the AP. Now see, when we have 3 numbers in an AP, consecutive numbers in an AP, what we can do, we can take A as the first term, A plus D as the second term. How do we get the second term of AP? By taking the first term and adding the difference. How do we get the third term of the AP? Take the second term, add the difference. So here the difference is D. So third term will be A plus 2D. It's A plus D plus D. That's the difference. So A plus 2D. But this way things sometimes may go difficult. So instead of taking 3 numbers in an AP like this, it is more convenient to take, we can take this term as A, the centermost term as A. The previous term will be how much now? A minus D. And the next term would be A plus D. So if you see, the difference is the same, it's D only. If you do A, second term minus first term. If you do A minus A minus D, it will give you D. And if you do third term minus second term, that is A plus D minus A, it still gives you D. So there is no problem. So this is much more convenient. So this tip you keep it in mind. 3 numbers in an AP should always be taken as A minus D, A and A plus D. Now which one will be the first term here? A minus D. Second term will be A. See the order. Third term will be A plus D. Now let us follow the instructions. The sum of the first 3 terms of an AP is 33. So A minus D plus A plus A plus D is 33. Let's work on it. This will give me 3A, this will get cancelled. 3A is 33, so A is 11. Now what have they given you? If the product of the first and the third term exceeds the second term by 29, if the product of the first and the third term, so this is the first term and this is the third term. So product of the first and the third term exceeds the second term is A, by 29. So let's see if this equation is correct. Product of the first and the third term exceeds the second term by 29. So plus 29 because it is exceeding. Now we need to just work on this equation. This is like A minus B into A plus B. So it will be A square minus D square is equaling A plus 29. A has already been found out. So substitute 11 square minus D square is 11 plus 29. So take D square on that side. 129 minus 11 minus 29 is D square. How much this works out to be? 121 minus, this will be minus 40. So 81 is equaling D square. So D will equal square root of 81, which is plus or minus 9. So now we have found A, we have found D. The question says find the AP. So we have to generate the AP. Now what is the first term? A minus D. So what we will do is we will take D as 9 in case 1. How much was A? 11. Okay, so first term is 11 minus D is 9. Second term is what? A. So that is 11. Then it is A plus D. So it is 11 plus 9. Okay. So this will be 2, 11, 20 and so on. See, it is not necessary that AP ends here. They said sum of first 3 terms of an AP is 33. Okay, so AP may be going up to 25 terms and they have given the information about the first 3 terms. So we cannot say 2, 11 and 20. We will have to say 2, 11, 20 ... It will continue. This is one possibility. Or D can also be minus 9. So now the AP will be A minus D. A is how much? 11 as we found out before. So other one will be 11 minus D is how much? Minus 9. This is the first term. Second term is 11. Third term is 11 plus D. A plus D. A is 11. D is minus 9. So this AP will work out to be 11, this 20, comma 11, comma 2, ... It continues. So 2 possible APs are generated. One this AP, other this AP. This happens to be increasing AP, this happens to be decreasing AP, but remember to put dot 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 because the AP continues. Comfortable with this? So we have finished sum number 4. Question 5. Find the 10th term from the end, not from the beginning. Find the 10th term from the end, and it is given 8, 10, 12 dot 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 up to 126. So 126 is the last term. Also find the sum of the last 10 terms. Mind you, it is not sum of the first 10 terms. It is sum of the last 10 terms. So first let us solve this part. Find the 10th term from the end. Now you may feel that okay, we can just apply the formula T10, 10th term. It will be A plus 10 minus 1 into D, but that won't be correct because they have told you 10th term from the end. Now see this logic. These are 5 terms. 1, 2, 3, 4, 5. If I say, so here n is 5. If I say find the second term from the end, so this will become the first term, this will become the second term. Mind you, find the second term from the end. So this is the first term, this is the second term. Now if I go from beginning, because the formula starts from beginning, it doesn't start from there. If I go from the beginning, so this is my second term. Okay. Let us see this second term from the end corresponds to which term from the beginning. Second term from the end corresponds to which term from the beginning. First, second, third, fourth. So second term from the end corresponds to fourth term. So total is what? 5. So it is not like that, okay, you say 5 minus 2. Second term from the end, matlab third term from the beginning. No, first, second, third. Third term is coming and sitting here, but we have to reach here. So it will be 5 total minus the second term plus 1. So this will become 4. So second term from the last corresponds to fourth term from the beginning if there are 5 terms. So how do we get total minus the second term if you want the second term plus 1. This will give the correct position from the beginning. Now here they said find the 10th term from the end. But we do not know how many terms are there here. Here I told you n is 5. 1, 2, 3, 4, 5. But this is just given a sequence and AP is given. We do not know how many terms are there. So first of all, we will have to find the number of terms. Then only we will be able to apply this logic. But anyway, this concept is clear because this is going to be used here. That logic which was explained to you is fine. Now let us first find the number of terms in this AP. So A is 8, D is 10 minus 8, that is 2. Now Tn is A plus n minus 1 into D. What is the nth term here? 126. This is 8 plus n minus 1 into 2. We have to find how many terms are there, given that the last term is 126 and the first term is 8. So 126 is 8 plus 2n minus 2. So 126 minus 8 plus 2 is 2n. So 118. Go in the order left to right. Whenever you have a series of addition and subtraction only, go in the order left to right. So 118 plus 2, 120. 120 is 2n. So n is 60. N is 60. That means there are 60 terms altogether in this AP. Now what we wanted? 10th term from the end. 10th term from the end. So what it will be as per the logic taught to you? Total minus 10 plus 1. So that comes to 51. So that means if I want to find the 10th term from the end, it is equivalent to finding the 51st term from the beginning. So eventually we have to find out T51 is question mark. So this amounts to finding T51 now. So 10th term from the end is equivalent to 51st term from the beginning. So T51 will be A plus n minus 1 into D. So 8 plus 50 into 2, 100, that is 108. So 51st term is 108. Now, so that we have found out. Now what the question says, also find the sum of the last 10 terms. See, every question which has been chosen here is a novel and giving you a good experience. These are not very direct questions. Also find the sum of the last 10 terms. So we are talking about finding the sum of the last 10 terms. So we'll have to start this AP from here. So now what will happen is A is 126 and your D will be minus 2, because if I am going in the reverse order, okay, 126, 124, 120, so 122, so D will be minus 2 here. Now we want to find the sum of the last 10 terms. See, this sum is not so tricky now, but what was tricky is finding the 10th term from the end. Now see how to go about. We can write S is equaling n by 2. So we know the last, how many terms are there now? 10, because they are telling you also find the sum of the last 10 terms. So it will be n by 2 into 2a, so 2 into 126 plus, what is the formula? S is n by 2 into 2a plus n minus 1 into d, or the equivalent formula was n by 2 bracket open first term plus last term, 2a plus n minus 1, n is 10 into d. So this would be 5, 252, 9 into minus 2 minus 18. Now this calculation you can do, you subtract and you multiply by 5, whatever answer it comes. This is one way of approaching. Other way what we can think is, the sum will be n by 2 bracket open first term plus last term. We know the first term here now, reverse AP, 126, and the last term will be what? 10th term. From here the 10th term, imagine 126, 124, 122, 120. This way we have to go up to the 10th term. And in the beginning we had found our 10th term. That was 108, because 10th term from the end corresponded to 51st term from the beginning. So from the end if I go, the 10th term is 108. So we can do that way also. So this would be 5 into this. I will show you both the answers are the same. So now this calculation if you perform, it comes to 1170. This calculation also if you perform, it comes 5 into 234, which is eventually 1170. So anyway you apply the concepts and logic, you are bound to reach at the same answer. So this completes your sum number 5. Question number 6, a word problem. In a flower bed, there are 23 rose plants. In the first row, there is a flower bed. In the first row, there are 23. Second row, there are 23 rose plants in the first row. Okay. In the second, 21 in the second row. 19 in the third row, and so on. So less, it reduces. So first row there are 23, second row there are 21, then 19, and so on. There are 5 rose plants in the last row. So final value is now 5. So first row there are 23, second 21, they are decreasing, third row 19, then it will be 17, and last row it is given to us that there are 5 rose plants. How many rose plants are there in the flower bed altogether? So total we have to find. So now what happens is, here this clearly forms an AP. If you see, A is 23 and it is going on decreasing. And the difference, so D is how much? 21 minus 23, that is minus 2. Again 19 minus 21, that is minus 2. Last value is 5. So first of all, we will have to find, we want to find how many rose plants are there in the flower bed. That means we need to find 23 plus 21 plus 19 plus 17 plus 15 plus dot 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 plus up to 5. So this is nothing but the sum formula, SN formula. Now for that, we first need to find N, otherwise we will get stuck in that sum formula. So let's find N. So Tn will be A plus N minus 1 into D. Now what is the last term here? 5. A is 23 plus N minus 1 into minus 2. Okay, this I will take it on this. So minus 18 is equal to minus 2 N plus 2. Take care of the signs while opening the brackets. 2 will again go there. So minus 20 is minus 2N. N is 10. That means altogether there are 10 terms in this AP. Now what are we supposed to do? We are supposed to find the total. Sorry. We are supposed to find the sum. So how will we find the sum? S is equaling N by 2. So there are 10 terms altogether. So 10 by 2. Now we can do 2A plus N minus 1 into D. But then luckily we know our last term. We know our first term. So we can use the second formula for Sn. That is first N by 2 bracket open, first term plus last term. So first term is 23, last term is 5. This gets cancelled, so we will cancel it. 5 into 28. How much is that? I will have to do and see. 28 into 5, 8 5s are 40. So altogether 140 plants are there in the flower bed. So these direct kind of word problems can be very much expected in the exam. Question 7 and the final question for this topic. Then you will have a good grip on this topic. Find the sum of integers. Find the sum of the integers between 100 and 200. So 100 and 200 will not be counted. That are divisible by 9. Second, not divisible by 9. So we will go by this, divisible by 9. That is easier to do. Okay. Now first we need to find which is the first number integer divisible by 9, and it should be more than 100. So to get an idea what you do 100 divided by 9 in the rough work column. That comes to 11 point something. Okay. We want a number higher than 100 because it is between 100 and 200. Means more than 100, less than 200. So 11 point something hai. So take 12. So 100 upon 9 is 11 point something, 99, okay. So take it 12. So now 12 into 9, 108. That means the earliest number greater than 100. The earliest number greater than 100 which will be divisible by 9 will be 108. What will be next now? 9 12s are 108. Now we will go on adding 9 because we can take now 9 into 13 because the first number is 108. Okay, 12 into 9, then it will be what? 13 into 9, 117. So there is a gap of 9. So what is the next number now? 126. It is very essential to get the first 2-3 numbers correct. Then only our whole sum will go right. Dot dot dot. We need to get the last number lesser than 200 now. So let's get a rough idea. 200 divided by 9. 9 2s are 18. 9 2s are 18. Okay, 2 remainder. So if I do 22 into 9, 22 into 9, 9 2s are 18, 9 2s are 18, 198. So 198 is that number which is lesser than 200 and is the highest number which will be divisible by 9. You all know the divisibility test for 9. This sequence will continue, AP will continue 108, 117, 126 up to 198. Now what we need to do? Find the sum of integers between this. So we just need to find the sum. So the main code was to get this. Now it is routine. A is 108. D will be second term minus first term. So that is 9. Okay. Now we will have to use the sum formula. S is equaling n by 2. S is equaling n by 2. But for that we need to find the number of terms in this AP which is not known. So before finding the sum, we will have to find the number of terms. So Tn is A plus n minus 1 into D. So my last term is 198. A will be 108 plus n minus 1 into D. D is 9. So we will have to solve this equation for n. So 198 is 108 plus 9n minus 9. So 198 minus 108 plus 9 is 9n. So how much this works out to be now? 198 minus 108. 90. 90 plus 9, 99. 99 is equaling 9n. So n is 11. That means in this AP there are 11 terms. But we are far away from our final thing. We want the sum of the integers. So now we will use the formula for the sum. N is now how much? 11. So the sum will be n by 2. We can go by 2a plus n minus 1 into D, or we can go by n by 2 into first term plus last term. Here we know the last term, so it is good. So let's use that. First term plus last term. N is 11. 11 by 2. Don't worry, don't take it as 5.5 and all. It will get cancelled somewhere. If it doesn't, then we will see. First term is 108. Last term is 198. So this will be 11 by 2. Let's add this. 108 plus 198. 8 plus 8, 16. 10, 306. Oh, nice. It is getting cancelled. To 153. So 153 into 11. Whatever is the answer. So So that would give us the answer for sum of the integers satisfying that condition, that is divisible by 9. Now we will come to the second part of this question. Okay, now for the second subpart, we need to find the sum of the integers between 100 and 200 that are not divisible by 9. So we found all the numbers that are divisible by 9. Not divisible by 9 will be what? Total numbers minus those numbers which are divisible by 9. So first let us find which are all the possible numbers between 100 and 200, all the integers. So it will be 101, 102, 103, up to 199. So it will be 101, 102, 103, up to 199. These will be all the numbers between 100 and 200. From these numbers, if we remove those numbers which were divisible by 9, then we will automatically get the remaining numbers will be not divisible by 9. So how many numbers are there now from 101 up to 199? Just see, 199 minus 101, that is 98 plus 1. So there will be 99 numbers. If you want to find what we can do A as 101 and D will be what? 102 minus 101, that is 1, and Tn is A plus n minus 1 into D. So that is 199 is 101 plus n minus 1 into 1. See, actually this can be done by easy judgment actually, but still you can go this way if you want. So 199 is 101 plus n minus 1. So this will be 98 plus 1 is n. So n will be 99. So altogether there are 99 numbers from between 100 and 200. From this, if I subtract all those numbers which are divisible by 9, what will I get? I will get those numbers which are not divisible by 9. Now let us find the sum of all these integers. S is n by 2. We can use first term plus last term, that would be faster. So 101 plus 199, that is 99 by 2. This will come to how much? 300. So 150 into 99, that works out to be 14850. Mind you, this is the sum of all the integers between a given range. What we have to find is, we have to find the sum of all those integers that are not divisible by 9. So how do we go about it? We will take sum of all the integers between 100 and 200, that is this 14,850, minus sum of all the integers that were divisible by 9, which we found in the first case. So for subpart 2, the required sum will be sum of all integers between 100 and 200, that is this 14,850, minus sum of all the integers that were divisible by 9, that was 1683. So just perform this subtraction and you will get the required sum of all the integers between 100 and 200 that are not divisible by 9. So you're okay with this sum? This was pretty long, but they would give you only like probably the first subpart, or sometimes they may not ask you to find the sum. They may just ask you to find how many numbers are there between 100 and 200 which are not divisible by 9. So in that case, what you do, you find all the numbers between 100 and 200 that are divisible by 9 and subtract this answer from the total numbers between 100 and 200. So then that will give you those numbers that are not divisible by 9. Done. We have completed this topic of arithmetic progression.